Hello, welcome back. So carrying on from our last work on transition metal solution precipitation reactions and ligand substitutions, I'm going to briefly go through these reactions here in terms of redox. Now this is going to be specifically to OCR, but there is a lot of crossover to the areas of the syllabus for AQA, EdXL, etc. Right, so to the point. So what we observe, because those are questions here, as well as why. So what we observe when we add H2O2 to Cr3+. Be very careful here, it says H2O2, not H2O. Do not skim read these. So H2O2 can act as both an oxidizing and reducing agent, but here it will be acting as an oxidizing agent. What we will see overall will be a green solution, and that becomes a yellow solution. Now the whys are a little bit more complex, because as well as the transition metal equations that I'm going to write, I'm also going to go on some extra paper to explain what's happening in terms of the redox equation, and these can be quite challenging as redox equations, especially when you compare them to what you've done early on in the course. But we'll start simple and build up to that. So what is actually happening? Well, overall the green solution, well, what we have here is this complex as before. So the reference to the green solution is this hexahydroxy chromium 3 plus ion here. Overall the complex is 3 minus. Now the yellow substance, there's space here for a reason, I'll come back to that, is because we end up with this bit here. Now we've got here, this is the chromate ion, and this is a yellow ion. So the way this happens, well, we're going to need overall 2 moles of this, make 2 moles of that, and we will need 3 moles of H2O2. At the end, we also end up with 8 moles of water. So this is the simplified version. I'm now going to explain how this comes about. Okay, so you need a little bit more paper. There is not enough space here at all. This is just a simplified version. Okay, right. So what's going off is 2 things. We are first of all using our H2O2, and that is acting as an oxidizing agent. So as an oxidizing agent, the hydrogen peroxide forms hydroxide ions at the end. So this is why hydrogen peroxide ends up being very corrosive. As well as removing electrons from things, it also produces a very, very alkaline solution at the end. The oxidation state of the hydrogen is +1. We can assume it's +1 because it's not bonded to a metal, which means when we add up the oxidation states, we've got here this oxygen in a -1 oxidation state. Over here, again, hydrogen is in a +1 oxidation state, which in this case, because the sum of the oxidation states is -1, this must be a -2 oxidation state. So now we need to balance up for our atoms. We've got 1 mole of the hydrogen peroxide, 2 moles of oxygen here, so we will have 2 moles of hydroxide ions being created. If we are going to go from a -1 to -2 oxidation state, from here to here, well, we are reducing this substance here. We are adding electrons to this substance here. So we need electrons. -1 to -2, 1 electron per mole of oxygen, 2 moles of oxygen, therefore we need 2 moles of electrons for this to happen. Now at the same time, we have our chromium. Okay, so this is in 3- overall. Now, this substance here, over the course of the reaction, as we add our hydrogen peroxide, becomes a chromate ion. For this to occur, well, we've got to change from one chromium ion to another, so these oxidation states are going to change. If we look here, well, we've got 6 hydroxides at -1, overall is -3, so this gives us a +3 oxidation state for the chromium. Now when we get over here, a little bit more complex, I'm just going to use my little method here. So the sum of the oxidation states equals -2. Oxide bonded to a metal, we can safely assume that that is -2 times 4, so we've got -8 from the oxygen. Now oxidation state here of X, so X take away 8 equals -2, so X is +6. So the chromium is going from +3 to +6. This is oxidation. For every 1 mole of chromium, we are releasing 3 moles of electrons. So that is going to get written there. So where does everything else go? Well, these oxides here, well, the 4 of them here, are already present over here for the hydroxide. So we end up with 2 moles of hydroxide being released. We also end up with 4 moles of H plus being released. But because we've got hydroxides and because we have got H pluses, we can cancel out those and 2 of those and replace that with 2 moles of H2O. So 2 of these H pluses, which were the 4, migrate for neutralization here. So this is what's going off here. So how do these go hand in hand? Well, with any pairing up of redox half equations, we need to have electrons balanced. So I've got 2 and 3 moles, so I'm just going to multiply one by the other. I'm going to multiply the top equation by 3, the bottom equation by 2, just so we end up with 6 electrons in each half equation. So multiplying the top one by 3, so 3 moles here, 6 moles there, and then 6 moles there. I'm going to multiply this line here by 2, so that's 2 moles there, 2 moles there, 6 moles here. That is then going to be 4H2O, make that a little bit neater, and here plus 4H plus. So now when we look at these 2 half equations, I've got 6 moles of electrons on both sides. So I'm just going to write these out. I'm going to sandwich them together just down here. So I've got 3 moles H2O2. I've got 2 moles of my chromium, and I've got 6 moles of electrons, which becomes, as we've said, 2 moles of chromate, 6 moles of electrons, 6 moles of hydroxide, 4 moles H2O, and 4 moles of H plus. So just sandwich them together. This is not acceptable to Mr. Examiner because we haven't cancelled out on both sides of the page. So what I can just do, I'm just going to cross through my electrons. That's taken care of. What I'm then going to do now, well, I've got 4 moles of H plus here and 6 moles of OH minus. So as before, I'm going to remove the limiting factor of acid or hydroxide. In this case, it's going to be limiting of acid. So I'm going to get rid of 4 moles of H plus and 2 moles of the hydroxide and create from that another 4H2O. That's what I've done there. I'm going to add these two together to give me 8H2O. So, and that just brings me back to that original equation that I wrote for you. So we now end up finally with 3 moles H2O2 plus 2 moles of the green chromium solution there. We end up with 2 moles of chromate, which is yellow. We end up with 2 moles of hydroxide and 8 moles of H2O. And that's what you should know for that box. And I'm going to leave that video as it is because it's coming up for 12 minutes and your brain's probably going to be a little bit mushed by that. So do watch that a few times, make your own notes and make sure you learn it for your exam. See you next time.